Today, I'll be demonstrating how cybercriminals use open source intelligence to create targeted and highly effective phishing emails that can establish a foothold for company-wide ransomware attacks. I'll show you what a skilled attacker can achieve in less than 2 hours with information available to anyone who knows where to look. So what is open source intelligence? In my view, it's anything you can find on the internet if you know where to look for it. There are many tools and techniques out there, but my favorite is Google. Google dogging or Google hacking is where you use crafted queries to find specific information that will never appear in the standard searches that we all make every single day. As you can see, adding in search operators such as in URL and file type along with sensitive keywords such as password, secret or confidential can return all sorts of interesting results. In the top two examples, I've shown leaked password files both on Amazon S3 Simple Storage Service and on a traditional website. Beneath that, you can see the result of a search on the code hosting website github.com for the phrases begin RSA private key and AWS secret. The credentials you can see give you VPN access into someone's corporate network and API access to someone's Amazon Web Services account. On the bottom right, I've used Shodan to find RDP servers which are publicly accessible from the internet. Someone will be brute force attacking all of these right now. Once they get in, they'll have a foothold on a network to start poking around, elevating the level of access, stealing data, and installing ransomware on anything they can see. That isn't actually how most ransomware attacks begin. The most common method today is with an email. The email is designed to tick all the right psychological boxes to ensure that the recipient either opens a directly attached file or clicks on a link to download a file from a website. The file contains malware, most often in the form of a weaponized Office macro. Visual Basic code which runs inside an Office document. Many organizations have Microsoft Office configured to prompt users to enable content before macros run to prevent them from running by default. But people see that button on every document with macros, and they get so used to clicking it they just do it out of habit. Even if you change the text to say execute malware, they'd probably still click on it. Once they click that button, the small built-in malware executes and downloads a larger piece of malware from the internet. This is a backdoor, granting them remote access from the internet into the compromised system. From here, they might as well be sitting in front of the computer. Cobalt Strike is a tool that was designed to allow ethical hackers to simulate attacks by cybercriminals. It is so good that cybercriminals ditched their old tools and started using it themselves. In order to bypass your corporate protections, the backdoor communicates with a command and control server over encrypted HTTP requests and DNS queries. Unless you're using a secure web proxy and DNS solution, these will pass straight through your firewalls onto the internet. With that backdoor installed, they start to probe around your network looking for ways to increase their level of access to company-wide admin. Then, they steal your data, encrypt your backups, and finally encrypt everything they can get their hands on. A little while ago, I was approached by a company called Tessian. They asked me to demonstrate to their customers how cybercriminals use open source intelligence to conduct phishing and social engineering attacks. Attacks which ultimately lead to a ransomware outbreak across an entire organization. I said sure, as long as I can use you as the target. They hesitated at first, but I promised to let them see the results before sharing with anyone. So the first thing I do when approaching a target, be it for bug bounties or otherwise, is to look at their company website to try to get a feel for who they are and what they're about. On their website, they had a really useful page with the names and photographs of their most senior people on it. It wasn't just those three, it was everyone, including their investors. I found a page which listed all their office locations, contact numbers, support, and press email addresses. I then had a look at their public DNS records. From this, I could see that they hosted their website behind Cloudflare, but their email records were pointing at Google Workplace. This is great as it tells me the type of controls they're likely to have in place. I then went to accounts.google.com and typed in admin@tessian.com into the username field. When I clicked next, it redirected me to a branded single sign-on page. This is amazing. Now I have the source code for a branded phishing page, which is identical to the one that Tessian users see every day. I then used an open source tool called The Harvester to scrape the internet for email addresses. I found a handful of addresses, most of them made up for Jane Doe or public addresses for customer support media inquiries, but one of them was for a real person. It confirmed that the company uses the format firstname.surname for employee mailboxes. This was another great find. With that information, all I needed to do was get a list of employees, and I had the email addresses of everyone. LinkedIn is great for this, but Google does it better when you limit your search results to the site linkedin.com and add the company name. I emailed someone in the marketing team a stupid question, and they replied, which gave me a copy of their official email signature. With that base level of information about how the company works, I started looking for individuals to target and ways I could almost guarantee a successful attack. Tessian have an Instagram account. Not many followers, but plenty of photographs. As I flicked through them, I learned that they were big fans of dogs and MacBooks. Not a single machine running Windows. I already knew they used Google Workplace from earlier on. That meant the traditional attack path of a weaponized Office macro was off the table. So then I had a look at their careers page, which was handily linked to from their Instagram profile. On there I found loads of helpful information. I learned that they're running predominantly on Amazon AWS, but they've just started a migration project to move away from Docker to Kubernetes running on Microsoft Azure. Their code backend stuff is written in Python 3 and front end using the React JavaScript framework. As always, I checked them out on GitHub. I found that they only had a single code repo with no members in the organization. But when I clicked into the Catapult repo, I could see 8 people who'd been working on it, with 2 of them tagged as Tessian employees. Putting it all together, the first thing I did was register a lookalike domain name. Thankfully, tessium.com was available. This changes the N to an M, which at a glance looks pretty much unnoticeable. I then signed up for a Google Workplace account in order to send emails from infrastructure identical to their own. My first phishing email was from Ed Bishop, the CTO. Hi John, I know you've been working on the Catapult AWS deployment tool recently. I've been trying to run some deployment auditing tools, but I've been unable to get them to work. Could you try this with your account and let me know if it works for you? Then there's a link to a Python tool that throws a weird error and steals his AWS credentials from his local machine. Phishing email number 2, from John to Jane, again using the Tessium with an M infrastructure. Hi Jane, I feel like I'm losing my mind. I've been trying to get the script to run all morning with no luck. There are no dependencies to install and Python 3 is up to date on my MacBook. I've even tried a clean install on a new VM. Could you help me please? What happens when you run it on your Mac? Then there's a link to a Python script that throws a random error after installing a Cobalt Strike backdoor onto her MacBook. Total investment, less than 2 hours and cheaper than dinner for 2 at McDonald's. So what can we do? First of all, get all the foundations in place. Patch everything, set strong passwords, enable MFA, remove everyone from domain admin or other company-wide admin groups, run phishing simulation tests, provide security awareness training, create offline backups that can't be changed by online systems and test them regularly. Install antivirus, install endpoint detection software, firewall everything down, make sure your attack surface is as small as possible, even inside your network. Cybersecurity is 80% doing the right things and 20% doing the clever things. There's no point doing anything fancy if you haven't got the basics right. Always assume that you will be compromised. Focus more on detecting problems and minimizing the damage that a single compromised PC or laptop can cause. Contain the outbreak as much as possible for as long as possible. Even if all you do is stall things, you're buying yourself more time to respond and stop everything before it goes too far. I know of attacks that have gone from phishing email to a fully ransomware company in less than an hour. And lastly, ransomware yourself. Well, not really. One of the exercises that I do is to walk through the recently released incident reports of disclosed breaches to see how long my controls will withstand that kind of attack. The recently leaked Conti Group attack playbook is a great resource for this kind of tabletop exercise. I use the feedback from these attacks to strengthen my controls and then do it all again. A real ransomware attack is the most accurate testing you will ever get. Doing it yourself with caution, don't actually break stuff, and make sure you understand what you're doing before you do it, is the closest you can get to the truth without actually having to pay a ransom. So to summarize all of that, these attacks are going to happen, so it's best to be prepared. The most important thing is to get the basics right, to stop the easy attacks from compromising you, and to make it as hard as possible to get that first foothold. But I expect that foothold to come one day, and when it does, be ready to contain it, to detect it, and to respond to it appropriately and quickly to minimize the damage that it causes, and to stop it from spreading and getting out of hand.